Okay, so here we are, College Algebra 2.3a, Systems of Linear Equations in Two Variables. And again, like I said in Chapter 1, this stuff should be review for you as far as being able to do the algebra here. The part that's new is actually using the algebra in the story problems. So that's pretty much the new stuff, but we're going to review system of linear equations in two variables, which means we are going to have two variables in each of our equations, such as y equals 3,000 x minus 7,200 and y equals 5,800 x minus 8,600. We have two equations and two variables, an x and a y. Okay, one of the things that's really important when it comes to algebra is that you can only solve for each of the variables. You can find out what number x represents, what number y represents, when you have the same number of equations as you do variables. So I have two variables. I have to have two equations in order to find out what my x number, what the x represents and what the y represents. So just something to keep in mind. If I had three variables, I would need an additional equation here so I could find the answer, and we'll get into that later. This section is just dealing with two variables, and in this case an x and a y. All right, the fancy schmancy little picture that I have up there is a graph of manufacturing in the United States as well as in China, and the blue is the United States, red is in China. All right, so what is happening in the year 2000? Well, China's manufacturing was quite low and the United States was high. Now notice the United States kind of stays the same, kind of has a bump here and continues to grow bit by bit, whereas China just kind of skyrocketed up there. Okay, so this is China's equation, the picture of their equation, and this is the United States. And the key part that we're going to be looking at is this right here, that intersection point. Okay, so for the red line, we are over at about, looks like about year 2013, and we go up about 2. So for China, x is 2013 and y is 2. Now let's look at the United States. To get to that blue point there where they intersect, 2013 and 2. So what does that tell me? That tells me that that point of intersection has the exact same x and y. Okay? So basically when you have a system of linear equations and they intersect, that intersect point is the answer. Okay, that's where both the x and the y's are the same for both this graph as well as this graph. It also tells you specifically in this graph where the United States and China, what year they manufactured the exact same amount of money in goods. Okay, it was in this year around 2013, and then look what happened after 2013. China did better than the United States did. Okay, so that was the point where things changed. At that point, everything was exactly the same. After that point, things changed. Okay, so that is what the graph tells you, and that's what we're seeking to do here, is to find out where the two lines cross. And then later on we'll get to some where the lines don't cross at all. But right now let's just look at where the two lines cross. Okay, a system of linear equations is a collection of linear equations containing the same set of variables, like I said earlier, an x and a y. And a solution to a system of linear equations is an ordered pair that satisfies both equations in the system, the place where those two lines or two graphs intersect each other. All right, so what we're going to do is we're going to solve for the two variables, the x and the y, by using three different methods. The first method is a graphing method. The second one is called the substitution method. And the third method is called the elimination method. So we're going to look at each one of those in this particular section. And again, this should all be review from Algebra 2, but let's go ahead and assume that it's been a while since you've had that, and the review might be helpful. Okay, so the first method we're going to look at is graphical solution of systems. All right, so let's say, for example, we have this equation, and we have this equation. And we either get out our graphing calculator or we use our XY, plug in a number for X, and it spits out a number for Y, and we do that. And we're able to draw this line right here. And we do the same thing here and are able to draw this line here. The solution to this system of equations, which means where this number here for X is the same number and where this y here is the same number, is where they cross. And at this point, they cross at 0.5, came over 0.5, and then down 5,700. Then down 5,700. And that part right there is the solution. If we put 0.5 in here for x, negative 5,700 in here for y, this will be a true statement. Take these same numbers and put them in here, and it will also be a true statement. If that's the case, then you just found the solution for the system of equations. Okay, so if you look at this graph, you can understand why it is going to be difficult to find the correct answer. For one thing, I don't know that this is exactly 0.5 over. It could be 0.56 over from 0. I don't know that this is exactly 5,700. I mean, from this graph, holy smokes. It almost looks like it might be 58 or 5,900. Okay, so you can't get an exact number very often when you're using graphing to find the solution. What you're doing is you're just getting kind of an estimate here, just kind of an idea of 0.5, negative 5,700. You know, you at least are given an idea of where your answer is going to be. Now, if you want an exact answer, you're going to have to use substitution or elimination, and we'll get into that in a minute. First of all, want to look at example 1 on break even. So a company is said to break even from the production and sale of a product if the total revenue, and if you remember, total revenue is the amount of money that a product is sold for, equals the total cost. Okay, so that means that the total revenue, the amount of money that they made off of the item, has to equal what it costs them to make. Okay, so that means that their profit needs to equal the total revenue minus the cost for the product. Okay, so we can say that a company breaks even if the profit is 0. So for instance, if the revenue they made off of this product was $10,000 and they're jumping up and down because they made $10,000, but now they have to figure out, oh, it costs us $10,000 to make that product. We made $0 off that product, but we didn't lose any money either. We broke even. So when the revenue and the cost are the same, then we can say that we broke even. And then from then on, as our revenue goes up, hopefully we'll make more and more profit. All right, so that being the case, let's suppose that we've got this company and it has as its total revenue for a product given by R equals 5585x. Usually that x is how many pieces of that item they sold. Okay. The total cost in the same problem is $61,740. Okay, so that would be how much setup costs were to get started. 440 would probably be the amount that it costs to produce the product. I mean, the cost of materials and labor after they paid for setup. And again, X is the number of units that they sold of that product. So the company is said to break even when the total revenue, this amount, when the total revenue equals the total cost, okay, or when R equals C. Okay, so again, I'm in example 1. It says, find the number of thousands of tons of the product that gives break even and how much the revenue and cost are at that level of production. Okay, so instead of using R, sometimes it's easier to use Y. So we're going to have one equation that looks like this. Okay, so that is the revenue function. And we're going to call the cost function, let's call this Y1 and this Y2, just so we know that we're talking about two different things here. That's all that Y1 and 2 mean. And we'll put down here, oops, there's no X there, is there? It goes after. Plus 440X. Okay, so there's our two equations. So we're looking for the break even. So the break even is where we graph this and we graph this, and those two lines intersect each other. That will be the break even point. Okay, now you can do that on the graphing calculator. You can do that just with a handwritten graph like this, and you graph this, whereas this does not cross the y-axis because there's no y-intercept. And we know that the slope is 5585 over 1. And so it's going to look something like that. Okay, the graph also is not going to go beyond 0 and be over in this negative because you can't sell a negative number of items. You're either going to sell 0 and be right here with no revenue at all, or you're going to sell some and get revenue. Okay, the other graph, this one right here, is going to be a graph that looks similar to this, and that is at 60,000. And the reason that we know that, or 61,740, I guess that's what that should be, because even when we've sold nothing and we're here, it still costs us $61,740 in order to get ready to produce the product. So that, you've already invested that much money. Okay, so where these two lines cross is that break-even point. Okay, which on this particular graph, you're gonna be kind of guessing where that's at. Because if this is 60, and I need to just take that off. If that is 61,740, and this graph is going uphill a little bit, golly, I can't really tell how high up that is, and I really can't tell how far over that is. The book shows it as this number being 12, and this number, the y value, how far up we went, so that's 12, and how far up we went they have as being around 67,020. Okay, there's no way you can look at that graph and figure that out, but you can get an idea that I don't have to sell tons and tons of these in order to hit my break-even point. Okay, I just have to sell, according to this, 12. Okay, this, because this is 12,000 tons, but we're just using regular old numbers here. Okay, so Again, that's to show that graphing doesn't give you a really accurate idea. Solving systems of linear equations using substitution and elimination are better. So, example number 2, it says to solve the system of linear equations. So we'll do that in the next video.